This is an iHeart podcast. Guaranteed human.
Okay, so my dog Little has figured out what a Chewy box looks like. And so she sees it and immediately assumes it's for her and goes rushing over to it.
Issa is the same way. She barks at everyone else, but the Chewy box, she's like, I'll let that one slide. You know what? I can't blame her. Chewy has over 100,000 products, food, treats, toys, beds, but all the stuff that both our dogs love.
And it shows up in like 1 or 2 days. Like I've barely hit the order button and it's already on my porch.
So convenient. And it's not just dog stuff. Birds, fish, reptiles. Chewy's got the whole pet universe covered.
You know what surprised me was the health side. Now, you know, my sweet Holly was a medically complex poodle with her heart disease and her kidney disease, and she needed a lot of prescription meds and prescription food. And Chewy was outstanding and really went above and beyond to make sure that she had what she needed. So I appreciate that. And Chewy will take care of all prescriptions, pet insurance, telehealth, vet visits. The list goes on.
And they're now rolling out actual vet clinics. So that is huge.
Amazing. And if Little turns her nose up at something, which she does quite often, I can return it within a year with no questions asked. And if I ever need help, Chewy's 24/7 customer service is actually helpful.
Chewy just makes the whole pet parent thing feel easier.
They really do. For life with pets, the answer is Chewy. Save $20 on your first order with free shipping at chewpanions.chewy.com/howrude.
Joy is essential, and it's also elusive. But now, there's a new and exciting way to start your journey toward a more joyful existence. Joy 101. It's a new podcast hosted by me, Hoda Kotb. If you're craving inspiration to maximize your joy, tune into these candid, uplifting, and moving on-air chats. Listen to Joy 101 on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts. Joy 101 with Hoda Kotb is presented by CVS.
Welcome to Stuff You Should Know, a production of iHeartRadio.
Hey, and welcome to the podcast. I'm Josh, and there's Chuck, and Jerry's here too, and this is Stuff You Should Know. Yet another edition of our never-ending, please don't ever let it end, Earth Science Suite.
That's right. Can I tell you a quick story?
Have at it.
You edged.
I know. I actually considered what I should say. Yes.
The astute listener would have heard you go, before you said yes.
Hopefully Jerry can edit that part out.
So I think I may have talked about this before, but I had aims at one point, and not like the most passionate aims, but I thought about being a meteorologist for a little while in college because I was headed toward a journalism major. And I think I'd mentioned before, my best friend from high school, the map illustrator today, Rad, we used to sit around and watch the Weather Channel, largely due to Rad's influence. And I just always thought it was cool. I took a meteorology class in college, and it kicked the poo-poo out of my body.
Yeah. I had a similar experience with astronomy.
Yeah, so I knew, like you wanted to be an astronomer, and then you're like, no, this is too hard.
I thought it was going to be like, look at this star. This is pretty awesome. And then like the first day, like the Sigma like sign shows up. I'm like, I don't know what to do with this. So I think I get where you're coming from.
Yeah, so that kind of dashed my dreams of being a meteorologist because, you know, I mean, I think people can teach themselves things, and like part of the hard part of our job is to teach ourselves something really like that people go to school for 4 years to study. And I think you can sort of teach yourself stuff, but unless you have just a fundamental weird innate understanding of that stuff, it's just really challenging. Like if you're not a math person, you can learn math, but not like someone who just really gets numbers.
Sure. Yeah, definitely.
Does that make sense?
Totally. And I'm not sure we've ever really, and by we I mean humanity, have put our finger on what that distinction is.
Isn't that weird?
It'd be interesting to know what some of the hypotheses are. Maybe we should do a podcast on it.
Yeah, that'd be good. So anyway, that's a long-winded way of sort of saying, you know, I did this over and over and studied wind the past couple of days, and I kind of get it enough for this show, but I'm not going to be a meteorologist for a very good reason.
Yeah, I'm with you. I've got it just enough that it feels like there's a massive opening on the side of my head, and everything I know about wind could just fall right out at any moment. But it's in there for now.
Yeah. Keep it shut for the next 45 minutes.
I'm trying. I've got my hand covered. It's really gooey in there.
Yeah. It's more complex than you would think, but some parts are easier as well.
Yeah, and I mean, like, even if you're talking about wind, you can kind of break down what wind is and what causes wind and what creates wind into basically three different things. The first one is heat, which we'll get into. Another one is pressure differences. We'll get into that as well. Okay. And then the rotation of the planet, which we will get into in this episode. But
that's where it gets a little tricky.
Yes. Agreed. Totally agreed. And I say we just dive in and we start with pressure differences creating wind, because I think it's the simplest thing to understand. And I think once you have pressure differences down, you can move on to the heat part.
Yeah. I mean, was this the Grabster? Did he help us with this one? Yes.
And I have to say the Grabster did an amazing job wrangling this info. Yeah.
No, hats off to him, because, Ed, I think Ed always has a knack of delivering a metaphorical type example that really hits home. And with pressure, he uses just a balloon filled with air where you have high pressure and low pressure. And when you take your fingers off the tip of that balloon, all that changes, because what wind is really always trying to do on planet Earth is equalize and reach some sort of equilibrium. And that's basically what's happening with wind. Is you have high pressure, which is technically more air, and that's going to flow away from itself because it wants to equalize. And then it's going to, where there's less air, the surrounding area is going to flow toward the lower area. So as it relates to wind, there's basically more wind, and the winds are faster when those two disparities are the greatest.
Yeah, if you get a parcel of air, which is just a kind of a stable mass of air as far as meteorologists are concerned, that's really high pressure, and you get one that's really low pressure, along the edges of those two places, there's going to be much higher wind than if they're a lot closer between high and low, if they're closer to the same. Yeah. And so that's wind right there. It just changes in differences in pressure, different parcels of air coming up against one another and saying, I'm going to fill you up. And then the other one says, fill me up. And that's the filling up is the wind, the movement of the air.
Yeah, so pretty easy.
I think so, yeah. It's just, where do those differences of pressure come from?
Are you asking me?
Yeah.
Well, they come from heat is a big source of where all this comes from, and you kind of, I thought you hinted, but then we did a different take and you rescinded that hint. But the sun, when it heats the earth, it heats the surfaces of the earth. It doesn't really heat the air so much as it heats the surfaces, whether it's water or land or like asphalt or sand or green grass, and they all have different temperatures. And that disparity is kind of the key to it all, because that's going to reflect back up, and that's kind of what heats the air, is the reflection of that sun onto these various temperatured surfaces, or not temperatured, but I guess ability to soak up that sun, maybe.
Right, yeah, because it's not at all uniform. Like you said, all these different kinds of materials found on the surface of Earth like absorb heat differently and radiate heat differently. So that means that the air above it that's getting heated by that land is going to be different than a different parcel of air like over water, right?
Yeah. And
so because heat has to do with pressure, and typically is associated with low pressure, heat warms air, makes it expand, which makes it less dense, which means it starts to float up away from the Earth's surface. And as it's floating up away from the Earth's surface, because of that equilibrium that air seeks, areas of higher pressure move in to fill that vacuum, that space that's being left by that lower pressure parcel of air that's floating up into space because it's warm.
Right. And this is that circular, it's called convection. Like, if you've ever bought or seen a bad infographic on a convection oven, it's bound to have like red pulsating circular arrows.
Right.
Kind of going up and then back down again in a circle. And that's what it is. That's all it is convection.
It's the same thing. Remember that Visions cookware in the 80s that you could see through?
Yeah.
So if you ever watched a pot of water boil in one of those things, that's convection as well. Like those bubbles going up, the hottest ones start to float, and they're replaced by cooler stuff that in its place starts to get heated up and starts to float. And so what you've got is basically like a circular conveyor belt, like a Ferris wheel almost, where the air that's heated at I think so too, especially if we're talking about one of those Ferris wheels where the little cabins spin all the way around on their own axis.
Oh,
terrifying.
Boy.
Yeah. So you've got a Ferris wheel, and as the Ferris wheel goes up, warm air that becomes less dense, and it rides to the top. And when it hits the top, it's colder up there than it is at the surface, so it starts to cool down, so it comes back down the other side. And as it's coming down because it's cooler, other air that replaced it before is going up because it's gotten warmer in its place. And it's just this constant moving Ferris wheel. Like you said, convection. That's convection. Rising and falling parcels of air in this case, but it can also be, bubbles of air in water for boiling or pockets of air in your convection oven or something. Right.
So now, everybody, we've talked a little bit about the Coriolis force or the Coriolis effect before. Mm-hmm. I don't remember what it was in.
I don't remember either because we definitely have talked about multiple times about your sink or toilet drain.
Right. So here's what I understand. The part where I get a little fuzzy is how, as it relates to wind, and I know that you've got that down. So I think we should make a pretty good dance partners here.
Awesome. Into one, into two.
But I do understand, like, the Coriolis force only affects objects that are moving around something that's rotating. And in this case, we're talking about the Earth. But, like, it's very easy for me to understand that if a plane takes off in Miami and tries to fly to Seattle, it's not like by the time it gets to Seattle, the Earth is going to be in a different position. So Seattle is, because it rotates. So Seattle's going to be in a different place. So when you look at the little flight map, it's not going. You can't fly in a straight line from Miami to Seattle. Mm-hmm. You have to fly on a curve to meet up with where Seattle's eventually going to be.
Yeah.
So that all makes sense to me. As it relates to wind, it kind of, even after reading this like 8 times, it's still a little hazy.
So the way that I saw it described that makes the most sense to me is that the Earth being like a sphere, or kind of like a sphere shape, but every part of the planet rotating, making a full rotation in 24 hours, means that some parts of the planet have a lot further distance to travel than other parts of the planet. So the equator.
Like the equator.
Yeah, the equator has to travel about 40,000 kilometers in 24 hours. But as you go closer to the poles, there's a lot further distance. I think at like 89 degrees north latitude, right below the North Pole, it has to travel 69 miles in 24 hours. Mm-hmm. So no part of the Earth can arrive before another part of the Earth within 24 hours. It just doesn't work like that. So some parts of the Earth travel more slowly than others. You got it so far?
Oh, yeah, that part's easy.
Okay. Now, what I saw was that if you fire, say, like a cannon from the equator toward the North Pole, when you're firing,
why would you go to war with the North Pole?
It's like one of those cannons that the cannonball is filled with candy. So it's not hostile at all. It's a very fun cannon. Sure. Yeah, exactly. I think we just invented a new great thing. So when you shoot that cannonball north toward the North Pole, you're shooting it at the speeds that the cannon was already traveling, which is something like 1,000 miles an hour on the equator. And as it gets further and further north, it's reaching a part of the Earth that isn't moving as fast as the equator. So that means that the cannonball actually appears to curve to the right because it gets ahead of the Earth as it's traveling. So that cannonball is going to land east of your target of the North Pole. Got it?
Yeah, but see, what's confusing me now is the thing that you sent me that said explained it best was from a surfing website, and it had to do with Spanish roundabouts.
Okay, that's another way to put it too. You want to?
Okay.
So we
have
the
cannonball thing though.
Well, we haven't quite reached that. I have one more part of the cannonball to say.
Okay.
If you're at the poles and you shoot a cannon toward the equator. Mm-hmm. You're shooting it from a slower place to a faster place. So the cannon is going to curve behind your target, to the west of the target. But to you, the person firing the cannon, it's still curved to the right. So no matter where you're firing a cannon from, whether the equator or the poles, it's going to curve the same way in the northern or the southern hemisphere, to the right in the north, to the left in the southern hemisphere. Now, we hit the roundabout part.
Okay.
Do you want to take that one?
Well, I mean, sure. It's sort of common sense. If you drive on the right-hand side of the road and you enter a roundabout, you're going to be going counterclockwise around it. And if you drive on the left-hand side of the road, it will be the opposite. Is it really that simple? Yes, it depends on which way the air is moving. So if you're talking about a roundabout, do you remember our episode we just did, the short stuff on the direction humans tend to travel? Yeah. Go to the right, usually, if you're certain countries. And we talked about how if you're entering a circle and you go to the right, you end up going counterclockwise. But if you're in the circle and you go to the right, you end up going clockwise. Oh, yeah. Okay. I remember the same thing happens. So if you have a high pressure system, air is flowing away from it. So that air is coming out of the circle. But any direction that air is going, say in the northern hemisphere, it's going to veer to the right. But since it's coming outside of the circle, that means that all of that air eventually is getting spun into a clockwise direction. Yeah. If it's going into that parcel of air, that circle of air, because it's low pressure, everything's coming into it at a right-hand angle, which means that the spin of the air is counterclockwise. I love it. I think it's really interesting. I was watching, as always, a lot of kids' science videos to learn this stuff. And one of them had a sort of a map of the hurricanes of the world. And as far as like the directionality, using just little lines and arrows. And it's just fascinating to look at the band of the equator. I don't know how wide of an area that is that deflects it, but there are no hurricanes at the equator or within that certain band of width around the equator. And it's just cool to look at, above and below the equator, how these hurricanes approach it and then almost are like, no, thank you, and go bloop, and just take a turn. Yeah, they get deflected by the convection currents there, right? Yeah, it's really fascinating. I think it's fascinating, too. I say we take a break and come back and talk more about wind of all things. Let's do it.
This is Jody Sweeten.
And this is Andrea Barber from How Rude Tanneritos.
Chewy has over 100,000 products. Food, treats, toys, beds, and everything ships fast.
And it's not just for dogs. Cats, birds, fish, reptiles. I mean, they got everybody covered.
Plus, prescriptions, pet insurance, and telehealth vet visits.
And vet clinics are rolling out now, which I love.
So many great things. And if your pet doesn't love something, return it within a year.
For life with pets, the answer is Chewy. Save $20 on your first order with free shipping at chewpanions.chewy.com/howrude.
Joy is essential, and it's also elusive. You can't order it, you can't borrow it, or simply hope it into life. But now, there's a new and exciting way to start your journey toward a more joyful existence. Joy 101. It's a new podcast hosted by me, Hoda Kotb. Together, guys, we'll have meaningful conversations with the world's most fascinating people. Entertainment legends, sports icons, wellness experts, and everyday people will share how they find, allow, and experience joy. And I'll offer some of my own tips and takes on seeking a more balanced and harmonious life. If you're craving inspiration, support, and useful tools to maximize your joy, tune into these candid, uplifting, and moving on-air chats. Joy after a breakup, joy as an empty nester, joy after a loss, joy as a caretaker. This new podcast will speak to you. Listen to Joy 101 on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
Things are getting eerie this week on Snafu with Ed Helms. My Favorite Murder hosts Karen Kilgariff and Georgia Hardstark join me for the unsolved kidnapping of William Morgan. It's a great true crime story filled with secret society intrigue and murder.
Freemason files.
Karen, you just birthed a conspiracy, and I'm here for it.
Yay.
Listen to Snafu on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
You can hear it, true, but now see it. Crime Stories now available with video episodes, free in the iHeart app. Watch all your favorite podcasts, full episodes, start to finish, gavel to gavel, soup to nuts, all in the free iHeart app. You can also watch all your other favorite podcasts like Hey Jonas, Las Culturistas, Post Run High, and so many more. Hear the voices you know. Now see them and see the moments you've missed. Open the iHeartRadio app, search video podcasts and crime stories, and then just tap watch. I'll see you on video, friend.
All right, Chuck. So you're talking about how the movement, the convection of air, combined with the Coriolis effect, creates cyclones and hurricanes, depending on what hemisphere you're in the world, right? Mm-hmm. It also, like that, a cyclone or a hurricane is a really tight weather system. They're rarely that tight. They're usually much more spread out and much looser, but generally the same thing. And because of those two things, the convection currents and the Coriolis effect, that means that air spreads around the world. It travels around the world. If we didn't have a rotating planet, we would just have a convection current that went from the equator to the poles, the equator to the poles, and that's it. But because of that Coriolis effect, it spreads around the world, right? And
that's right.
As it kind of spreads around the world, it's also kind of staying within a certain number of latitude and forms these large giant cells so that each band of latitude around the world generally has its own weather.
Yeah, I mean, this part is really cool, and it makes perfect sense. You know, the equator is where it's going to be warmest on planet Earth. And as the air is, reflected back up with the Coriolis effect, and it goes further north, it's going to start cooling down. Mm-hmm. And they've basically figured out at about 30 degrees latitude, it will have cooled down enough at that point to finally descend again. But when it's descending again, it's always seeking that equilibrium. So it's going to be pulled back toward the equator again by the low pressure caused by it heating and rising to begin with. So again, it's that convection cycle, but they figured out that it's about 30 degrees where that temperature change finally is enough for that to happen again.
Yeah, and so because of that Coriolis effect, you have high atmosphere winds traveling from west to east, and then when they descend, they come back down from east to west, and those form the trade winds in this giant cell that's called a Hadley cell, which is between the equator and, like you said, about 30 degrees north latitude. That's
right,
one
and there are
cell.
two of those.
Yes, there's one in the north and there's one in the south. And then
That's right.
around the poles, there are two other cells, appropriately called polar cells. And because it's so cold, the equator has its cells because it's so hot. The poles have their cells because they're so cold that any difference in temperature is like a radical difference in temperature. So they have their own convection currents that operate at the poles as well.
That's right. And like you said, that's the polar cell that hits at about 60 degrees. And it's just two basically temperatures of convection happening on both sides of the Earth. And then in between, you've got what's called the Ferrel cell, Ferrel. Mm-hmm. And this is between 30 and 60 degrees, obviously, roughly. And right here, it's, the heat differential isn't that much. It's not the, super, super cold or super, super hot. So you're not going to get as much like radical convection going on. And most of the movement there is caused by the Hadley cell below it and the polar cell above it, sort of knocking it about in between.
Yeah, which is really cool because that means that the friction from the Hadley cell below it and the polar cell above it are actually spinning the air in the Ferrel cell. And because the polar cell and the Hadley cell are both spinning counterclockwise, they're like gears turning a cog, and that cog is the Ferrel cell. And because they're both spinning counterclockwise, they spin the Ferrel cell clockwise.
That's right.
That's just so amazing to me that this is happening at all times on planet Earth.
Yeah, invisibly.
Yes, and because of the tilt of the Earth on its axis as it rotates, which gives us the seasons, the different strengths and amounts of this kind of movement of air and where they are within that band of latitude that they exist in changes over the course of a year, which gives us different kinds of weather on different parts of the Earth over different times of the year.
That's right. And all of this stuff going on, all of these, the Hadley cells, the polar cells, and the Ferrel cells, all interacting with the Coriolis force that we talked about and that you wonderfully explained with candy cannons. And all these different pressure gradients that we explained at the beginning, all of this stuff together causes the jet streams. If you've ever flown, there's in an airplane, and they say we can make up some time if we fly a little higher, or, if we're going, east to west or west to east, things are going to, like, your speed's going to be different because of these jet streams. They're super powerful and very focused wind bands, a few hundred miles wide, that just wrap around the planet. And the polar jet stream, that's the money one. That's where you're really going to be able to, like, utilize an airplane's efficiency at its maximum. The subtropical jet stream isn't as powerful, so it doesn't get as much press. But the polar jet stream can go like 200 miles an hour.
Yeah.
And that's when, when you fly up in that thing, that's when it's like walking on a moving sidewalk in an airport.
Yeah, but one that goes 200 miles an hour, so hang on to your hats.
Right. So you're still walking, but you're getting that extra boost.
Exactly. And the reason the jet stream is so powerful up north, the polar jet stream, is because the difference in temperature between the polar cell and the Ferrel cell is much different. It's much greater than the difference in temperature between the Hadley cell just above the equator and the Ferrel cell between the polar and the Hadley cells, right?
Right.
And because of that temperature gradient, there's density differences. So air moves really, really fast, and it wants to go from the north, from the poles, toward the Ferrel cell into the mid-latitudes. But it can't. It can't go all the way down because the pull of the Coriolis effect is such that it stretches it out into a stream. And it's a messy stream. It's not like a clear, easygoing stream, and it changes from point to point around the Earth, and depending on the time of the year and even time of the day, I would imagine. But it stretches it out. And sometimes when the difference in temperature is so extreme, the jet stream can actually come down further south. And that's what happens. Remember when we get a polar vortex every once in a while?
Mm-hmm.
That's the northern polar cell extending like so powerfully into the United States, into the heart of the Ferrel cell, where most of us in the U.S. live.
Right.
I just think that's fascinating. And if you want to see that like in action, there's a really cool video called NASA Satellite Sees Polar Vortex on the Move. And it's, I guess, satellite imagery of the moving polar cell as it creates a polar vortex. It's pretty cool. And it kind of gets across, like I said, just how messy the jet stream can be.
No, it's awesome. This, I think it's pretty cool. Ed points out that it was really World War II where we really started to understand the benefits of the jet stream, because there were just so many more planes than ever before. People are like, wait a minute, there's this jet stream up there, and we can really use this to save time and fuel and money and get advantage on our enemies, perhaps, because we're moving faster. And even though in the 1800s, you might see volcanic smoke like hundreds and hundreds of miles away, thousands of miles, because it got caught in the jet stream, and like they recognized this, but there weren't planes, so they didn't really understand, like it didn't really matter, basically.
Right.
Because we're here on Earth, who cares?
Yes. So what we've been talking about so far, Chuck, like the jet stream, it's a very high altitude parcel of air or movement of air, stream of air. I guess I'll just go ahead and call it that. But there's other things that also like affect wind as well, and it has to do with the differential between the land and the sea, and then also the topography of the land as well.
Yeah, so if you've ever gone to the beach at all, you know that it's cooler near the beach and near the ocean than it is inland. If you ever lived in Los Angeles, I think Matt Groening had a very funny quote years ago. Someone interviewed him. What did they say? They said something like, if you could give advice to anyone about living in Los Angeles, what would it be? And he said, I think all he said was, it's cooler near the ocean than it is inland. Some very kind of funny quip about that. But it's true. You know, when you drive toward the beach in LA, it just the air gets cleaner and cooler. And it's like someone flicked on the air conditioner generally. And that's because those temperature differences that we talked about of water and land, like the sun is heating this stuff up. It's heating up all that inland asphalt and everything else, even the ground and the grass. And it's heating the water differently. And ergo's not right, is it? Therefore?
Erstwhile.
Ooh, I never use that. I like that. So erstwhile, the reflected heat is going to be different over the water than over the land. And the land is obviously going to be warmer, so the air above it is warmer. That air is going to rise and create a low pressure system, and it's going to pull that cooler air from the water back toward the land. And if you're on the beach or near the beach, you're just getting the benefit of that cooler air being pulled in. Yeah, and if that didn't happen, that Frank Sinatra song, Summer Wind, would not exist. Oh, man. What a great song. Even more importantly, there would not be one of the greatest endings to any Simpson ever, speaking of Matt Groening. The end of the Bart of Darkness one where Bart breaks his leg and ends up doing a spoof of Rear Window, and the Simpsons get a pool. And Martin Prince gets a pool to compete, and he wants to be popular too, but his pool bursts, and somebody, I think Nelson Muntz, pantses him, and he just stands there singing Summer Wind at the very end with his pants pulled down around his ankle. I don't remember that. It's as good as that episode's just fantastic. That's where Millpool came from. I mean, it's just top notch. I love that song too. It's so great. Yeah. So we need to talk about mountains too, because we talked about ocean and how that the ocean and how that topography can change how wind acts. But mountains, simply get in the way of wind. If you've ever been hiking, it's much windier on the top of a mountain because there's simply nothing in the way, and that has a lot of weird effects on how the wind travels, right? Yeah, like if there's like a gap in between mountains, it actually funnels the wind together, which makes it much higher pressure because there's a lot more air in one smaller space. That can definitely affect wind speeds. And then also when it hits the mountain, like you said, because the mountain got in its way, it goes up and then comes down the other side. And on the other side, there's all sorts of weird turbulence that is really hard to plan for, which is apparently why flying in and out of Las Vegas can be a difficult takeoff or landing because of that turbulence from, I think, wind coming from the west to the east. Yeah, I feel like there's been a lot of movies where like a helicopter crash has happened. In real life range. Yeah. Yeah. But yeah. Movies based on real things, probably. Exactly. So you want to take a break, Chuck, and then talk about all the things that wind does for us? Yeah, wind does a lot of things.
Okay, so my dog Little has figured out what a Chewy box looks like. And so she sees it and immediately assumes it's for her and goes rushing over to it.
Issa is the same way. She barks at everyone else, but the Chewy box, she's like, I'll let that one slide. You know what? I can't blame her. Chewy has over 100,000 products, food, treats, toys, beds, but all the stuff that both our dogs love.
And it shows up in like 1 or 2 days. Like I've barely hit the order button and it's already on my porch.
So convenient. And it's not just dog stuff. Birds, fish, reptiles. Chewy's got the whole pet universe covered.
You know what surprised me was the health side. Now, my sweet Holly was a medically complex poodle with her heart disease and her kidney disease, and she needed a lot of prescription meds and prescription food. And Chewy was outstanding and really went above and beyond to make sure that she had what she needed. So I appreciate that. And Chewy will take care of all prescriptions, pet insurance, telehealth, vet visits, the list goes on.
And they're now rolling out actual vet clinics. So that is huge.
Amazing. And if Little turns her nose up at something, which she does quite often, I can return it within a year with no questions asked. And if I ever need help, Chewy's 24/7 customer service is actually helpful.
Chewy just makes the whole pet parent thing feel easier.
They really do. For life with pets, the answer is Chewy. Save $20 on your first order with free shipping at chewpanions.chewy.com/howrude.
Joy is essential, and it's also elusive. You can't order it, you can't borrow it, or simply hope it into life. But now, There's a new and exciting way to start your journey toward a more joyful existence. Joy 101. It's a new podcast hosted by me, Hoda Kotb. Together, guys, we'll have meaningful conversations with the world's most fascinating people. Entertainment legends, sports icons, wellness experts, and everyday people will share how they find, allow, and experience joy. And I'll offer some of my own tips and takes on seeking a more balanced and harmonious life. If you're craving inspiration, support, and useful tools to maximize your joy, tune into these candid, uplifting, and moving on-air chats. Joy after a breakup, joy as an empty nester, joy after a loss, joy as a caretaker. This new podcast will speak to you. Listen to Joy 101 on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
You can hear it, true, but now see it. Crime Stories now available with video episodes, free in the iHeart app. Watch all your favorite podcasts, full episodes, start to finish, gavel to gavel, soup to nuts, all in the free iHeart app. You can also watch all your other favorite podcasts like Hey Jonas, Las Culturistas, Post Run High, and so many more. Hear the voices you know. Now see them and see the moments you've missed. Open the iHeartRadio app, search video podcasts and crime stories, and then just tap watch. I'll see you on video, friend.
Things are getting eerie this week on Snafu with Ed Helms. My Favorite Murder hosts Karen Kilgariff and Georgia Hardstark join me for the unsolved kidnapping of William Morgan. It's a great true crime story filled with secret society intrigue and murder.
Freemason files.
Karen, you just birthed a conspiracy, and I'm here for it.
Yay.
Listen to Snafu on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts.
All right, so we're going to talk about what wind does. What good are you, wind? Well, if you like weather, you can thank wind, because wind basically creates the weather that we feel as humans walking around on planet Earth. It's going to pick up moisture and then drop that moisture again and give us beautiful cleansing rain. It's going to affect the temperature because, like we said, it's moving air of different temperatures all over the Earth, and that air is going to change the temperature where you're standing.
Yeah, I mean, it's weird to think of, but weather is just wind plus water mixed together in different interesting ways. But that's it.
Oh, I thought that was the definition of comedy. Oh, no, wait, that's tragedy plus time.
Yeah. Man,
okay.
You just busted my brain, Chuck.
Wind plus water, right, not the same.
So depending on where you are on the Earth, it can be windier than other places. And in fact, I think for a long time, for a good 70 years, maybe 80, the highest wind speed record ever recorded was on top of a mountain in New Hampshire.
Yeah.
It was exactly Mount Washington, part of the presidential mountains, it turns out. Get this, there's like President Jefferson, President Washington, and then President Eisenhower.
What, these mountains?
Yeah, that's the name of the mountains in this presidential mountain range. I just think that one sticks out a little bit.
It's a big leap.
So on this mountain, they recorded a wind speed of 231 miles an hour in 1934, and that stood all the way until, I think, 2011, when it was finally confirmed that something that had happened years before in Australia knocked the Mount Washington record off of the top of the peak, I guess, as it were.
Yeah, I think this was in 96 is when it actually happened. There was a 253 mile an hour gust. But this was the interesting thing here is this was during a tropical cyclone. It was named Olivia at Barrow Island, Australia. And I think, like you mentioned, it was only confirmed in 2010. Mm-hmm. But the interesting thing is that Mountain Washington, this was not a hurricane happening, obviously, in Mountain Washington, New Hampshire. This was just a massive pressure gradient and a multiple storms, sort of like the perfect storm, crashing into one another. And then obviously, Mount Washington, that we already talked about the wind being greater at the top of a mountain. But usually, like, you would expect a wind record to be during a hurricane, and that wasn't the case.
No, but also I read that the jet stream dips frequently near Mount Washington.
Oh, interesting.
So it had the advantage of the jet stream adding in there too. Oh. Apparently, they bill themselves as the place with the world's worst weather. Like they have hurricane-forced winds, like 100 days of the year, and they are definitely hanging on to their status as much as they can. I think
right. And tornadoes, we should point out, don't count because you can, there have been 300 plus mile an hour winds during tornadoes, and those are just separate records.
Yeah. And then actually, like, we measure wind speeds from things like cyclones and hurricanes certain ways. So there's a scale called the Saffir-Simpson scale, which I'm sure we talked about in our hurricanes episode. Yeah. But that ranges from category 1 to category 5, and they base it on wind speed and potential for damage. And then for tornadoes, there's a scale that also has to do with damage, like how destructive the tornado was. It's the enhanced Fujita scale, and it goes from 0 to 5. I think we talked about that in our what's it like inside a tornado episode.
Yeah, because one person survived it and told their story.
Yeah.
And everyone's been writing that story since then.
That's exactly right.
All right, we can go through some of the more things that wind does because it's pretty remarkable. It doesn't just give us weather. If you've ever been to the beach and looked at waves and thought they were kind of cool, you can thank the wind for that. And we're not talking about, obviously, like under the surface of the ocean where tidal forces are at work. We're talking about winds blowing across the surface of the ocean and literally pushing ocean water and circulating this water in what's called a gyre, which can move, it can be great. It can move nutrients and stuff like that and help marine mammals with their migration patterns and stuff or marine animals with their migration, but it can also move around great garbage patches, as we've talked about in the past.
Yeah, we did an episode on that too. Ed uses this example of how water can actually pile up, which is just so fascinating to me. When wind is strong enough and persistent enough, it can actually push water so that, like, the either end of a lake, like Lake Erie, can have a difference in surface level of like 15 feet. Like, it's just all the water happens to be on the east end at that time because these seasonal winds pushed it down that way. That's just nuts. Like, I always think water's level. It's just always level. Nope. Our friend wind makes it not so.
Yeah, and I think Lake Erie is even a standout in that it's at one end. It's a phenomenon called a seiche. But from what I read, I looked up on seiches a little more. I think that's usually water piled up higher at both ends, and it's lower in the middle. It's like less oscillation in the middle.
Like Moses.
And they kind of likened it to a seesaw. Like if you look at the center of a seesaw, it doesn't, it's not moving as much as both ends are.
Gotcha.
But I guess in Lake Erie, that wind goes one direction, and it's just stacking up there on the east side.
And the planet tilts a little bit when it gets too piled up on one side of Lake Erie.
Does it really?
I don't think so. Maybe, but probably not in any way we're equipped to detect at this point.
You can really take advantage of how little I understand all this just by saying things like that with a serious tone.
All right, good to know. I wish you would have told me that at the outset of this.
Yeah, you could just make fun of me this whole time.
Another thing wind does is help spread plants far and wide across this earth because a bunch of plants have evolved to disperse their seeds by hitching a ride on the wind, huh?
Sure. I mean, a lot of plants are built to do just that, whether it's the way where they're shaped, like, if you think about a little dandelion, I mean, talk about something that was made to move with the wind.
What are those whirligigs, the helicopters? What tree is that? Are they maples that do that?
I don't know, man. I always call them helicopters.
Yeah, but it's like, it's almost like more like a clothes hanger, like the old fat wooden ones with a seed in each end to balance it out. And it just spins down, like a helicopter rotor. And I mean, like, they were all over when I was a kid, but I cannot for the life of me remember what tree they came out of.
Yeah, and I don't think I feel like I see them like I used to.
Huh. I wonder if that species has gone extinct.
No, someone will let us know what it is. I'm sure they're everywhere, but that was certainly made to move on the wind. Ed pointed out something I had no idea. It's kind of a cool little factoid, which is when you go out west and see, first of all, when you see your first legit tumbleweed, it's kind of a nice moment because it just seems like something from the movies. But when you see it, you're like, oh, wait a minute. That's a real thing that happens. There are tumbleweeds out west. They're dropping seeds all along the way thanks to wind.
Yeah. So they're a seed dispersal unit is what you call it. Pretty neat.
An SDU.
It also carries dust for better or for worse. We did an episode on desertification. We also did one on droughts. And in both of those, I think we talked about the Dust Bowl of the 1930s, where the middle of the United States was turned into a desert because we didn't know what we were doing with soil tilling, which led to erosion, a terrible drought, and some really high winds that just basically blew all the soil westward, I believe, and blew basically everyone who lived in Oklahoma westward as well to settle out in California. It can also, over time, over long enough time, wear down, those same geological features that get in its way, huh? Sure.
I mean, a mountain, the Appalachians are smaller now than they used to be. And that's because wind. Wind has just sort of eroded those over time. And they're still wonderful and great, but it's not like the Rocky Mountains out west.
No, but they're about 400 million years older than the Rockies, so give them a break. Yeah, which
is why they're stumpier.
But so as wind taketh away, wind also giveth. And they think actually because of dust storms from North Africa, from the Sahara, being kicked up and carried all the way across the Atlantic, which actually sometimes, if it's good enough or strong enough, can cut down on hurricane season rather dramatically because it keeps tight systems from forming. But they suspect that possibly this dust, which is nutrient rich, which makes land in some part in South America, may have contributed to the Amazon rainforest being so lush.
That's amazing.
Yeah, it is. And Chuck, what's causing that?
Wind.
That's right.
But like you said, it can taketh away. Wind can carry disease in that dust as well. And they're also from Africa. They think there have been some meningitis outbreaks around the world because of these Harmattan winds that have carried it with the dust. And I guess the theory is that dust particles are going to carry a virus more effectively from person to person. I know they've even talked about that with COVID.
Yeah. Yeah, I remember that too.
Like the reason why masks are effective, because I know at first there was a lot of people going, oh, these particles are so small, they can get right through those masks. But the particles are carried on droplets, and the droplets don't get through. It's the same theory with the dust.
Very nice. Thank you for the COVID update too. It's been a little while.
Yeah, it's still out there, everyone, just in case you're wondering.
Yeah, hasn't gone anywhere. You got anything else about wind, one of the coolest things on the planet?
No.
Okay,
wind blows.
Yeah, it does. If you want to know more about wind, then just start researching. Maybe you'll be a meteorologist. You can pick up where Chuck left off. And since I said that, it's time for listener mail.
Pick up where I left off, which is to say, after one class
That's right.
that I made a C in.
You got to start somewhere.
All right, this is, I'm just going to say this is one of the nicest thank yous that we've gotten in a long time, and it meant a lot to me, so we're reading it.
Okay.
Hey guys, want to write in and thank you for putting the superb content out in the world for people to enjoy. Appreciate that your show informs and educates, but even more importantly to me, your opinions give me perspective on my own thoughts and beliefs, and I often find myself participating in introspection to check myself on outdated ideas that haven't been challenged by my friends and peers.
Wow.
You bring a modern, thoughtful approach to your outlooks on life, and I can't tell you how helpful it is to have that presented in a friendly and accessible way. It takes work curating one's media intake nowadays to avoid negativity, divisiveness, and bias, and having a platform like Stuff You Should Know that I trust to always put the best foot forward, we try to, my friend, is immensely appreciated. The impact you both had on me and countless other people helped shape a healthier, happier, and more inclusive generation. And for that, Thank you hardly cuts it. I know, right?
Man, that was one of the best thank yous ever, huh?
If you're ever in Austin, the barbecue and the drinks are on me, and that is from our new best friend, Tom Tapp.
It gets even better. He offered barbecue and drinks for free, Chuck. For free.
No, you don't have to do that, Tom, but
no.
If we ever come, how about this? If we ever come back to Austin, Tom, you, my friend, and your +1 are on the guest list.
Listed. Tom just got listed.
Just write us an email from that same thread, Tom, to remind us and say, hey, buddy, remember me? You promised me free tickets.
Yeah, and to prove you are who you say you are, Tom.
Well, I mean, if someone wants to go through the trouble of getting a fake ID that says Tom Tapp,
yeah,
then I guess that could probably work.
I would not encourage that. I think.
But if someone writes in and says, hey, I'm the guy, but my name is, Bobby Juniper.
Tam Top.
Tam Top.
I got it mixed up.
I don't know where Bobby Juniper came from. That's
I don't know.
Hotel check-in name.
That's a great one. It suggests that you smell really nice,
Sure.
And all you need to do is make that suggestion, and people will take it and run with it. And as far as they're concerned, you do smell nice. If you want to be like Tom and send us one of the greatest, nicest thank yous ever, we would sure appreciate that. But that's not the only reason you have to write in. You can write in for any reason. Whatever reason you write in for, you can send it in an email to stuffpodcasts@iheartradio.com.
Stuff You Should Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.
This is Jody Sweeten.
And this is Andrea Barber from How Rude Tanneritos.
Chewy has over 100,000 products. Food, treats, toys, beds, and everything ships fast.
And it's not just for dogs. Cats, birds, fish, reptiles. I mean, they got everybody covered.
Plus, prescriptions, pet insurance, and telehealth vet visits.
And vet clinics are rolling out now, which I love.
So many great things. And if your pet doesn't love something, return it within a year.
For life with pets, the answer is Chewy. Save $20 on your first order with free shipping at chewpanions.chewy.com/howrude.
Joy is essential and it's also elusive. But now there's a new and exciting way to start your journey toward a more joyful existence. Joy 101. It's a new podcast hosted by me, Hoda Kotb. If you're craving inspiration to maximize your joy, tune into these candid, uplifting, and moving on-air chats. Listen to Joy 101 on the iHeartRadio app, Apple Podcasts, or wherever you get your podcasts. Joy 101 with Hoda Kotb is presented by CVS.
This is an iHeart podcast. Guaranteed human.